Hi, in this video we are implementing random forest regression. So implementation of random forest regression. So we shall be using our Python code to give you the idea that how this random forest regression can be implemented using the random forest regression class objects. Here we'll be using the dataset that is the Boston dataset. So let us go for the implementation at first for more discussion on this topic. Here we are discussing one sample program in Python on random forest regression. So here we'll be dealing with a dataset, and this dataset is the Boston dataset. So let us concentrate on our code. So hash load libraries. So here we are having one comment. Here in this particular cell we are loading the required libraries. That means from sklearn.ensemble we are importing random forest regression, and from sklearn also we are importing datasets. We can also read this Boston dataset from our local hard disk or from our the local path. But here we know that in case of sklearn, the respective datasets. So this particular datasets is containing so many different datasets like your Boston, IDs and so on. So now we are going for loading this dataset. So how to load this dataset onto a variable that is a Boston. So Boston is equal to datasets dot load Boston. So load Boston is a method. And then if you want to print the Boston dot keys, so we know that Boston is nothing but it is one dictionary. Dictionary is a key value pair. So dictionary is a key value pair. So now what is happening? So see, here we are going to print only the keys. So what are the keys it is having? It is having only 3 keys, 4 keys rather. What are they? That is the data, target, feature names and descriptions. And if I want to print the whole dictionary, we are getting this one. So now see, for the data, for this against this particular key we are having this array, and then array of lists, and then we are having this target, and here we are having one, the list is there, array of lists, and then we are having this one as a feature name. So these are the feature names. How many feature names are there? 13 feature names are there. Then we are having the description. So this is the content of this Boston dictionary. So how many keys are there? 4 keys are there. And what are they? They are nothing but data, target, feature names and description. So here we are having how many records, how many particular number of target values we are having. Here we are having total number of target values is 506. So here we are having 13 attributes and then 506 number of rows are there. So now from this Boston dataset, we are going to take only the first 2, that is the 0th column and the 1 column. So column number 0 and column number 1, and but we are taking all the rows. So how many rows we are taking? Actually we are taking 506 number of rows. And then for the target and this Boston.target, so the respective values are getting assigned onto this y. So capital X containing only 2 feature variables and small y is containing the output. So now let me print the length of this y, and it is 506. So what is the current content of X? There is a 506 number of lists are there, and this particular list is containing 2 data items. Each list is containing 2 data items, that is the column number 0 and column number 1 of the Boston dataset. And what about this y? This y is having 506 number of values are there. Okay, now we shall go for the create random forest regression. So create decision tree and classifier object. We are having one class that is a random forest regressor. We are passing the random state is equal to 0 and n jobs is equal to -1. What is a random state is equal to 0? So depending upon this particular seed value, the random numbers will be generated, and this is a random underscore state. So it is one parameter to this random forest regressor. And what about this n underscore jobs is equal to -1? This -1 is indicating that so allocate as many as CPU possible and available. So that is n jobs is equal to -1, because if we have the multiple CPUs got allocated for this particular process, then obviously the process execution will be faster. And if you print this regressor object, we are getting this one. You can find that here the n jobs is equal to -1, whatever I have passed, and the random underscore state is equal to 0, the value whatever I have passed, and rest of the input parameters, so they have got the default arguments. So next we are going for the fit. We know that fit means what? Fit means the trend. So this particular x and y will be passed as input argument to this fit method. So this method will take this x and y values and it will train itself, and in this way the model is getting trained. And almost for all the classifier objects, we are having the method called fit, with the help of which we can make the model train. So that, what is the meaning of the term training? Training means actually it is trying to get the data pattern existing in this x and y. Now how many features we took? We took only 2 features. So now we are having the feature importances. So you are having the first feature is that is a feature number 0 is having the importance value, that is a 0.8, and in the second one it is having the feature importance value, that is 0.1. And how many features did we use? So that can be also getting calculated by printing this regression object dot n underscore features underscore. So in this way I have shown you that how this random forest regressor, this classifier object, can be defined, and how to make the model trained with my x and y values, and why we are writing. So here we are finding this capital X and the small y. This capital X is indicating that it is having multiple feature attributes, and small y is indicating the required output of this particular the data set, because the data set is having one output variable or response variable, and it might be having multiple input variables or the feature variables. So in this way this particular regression, random forest regression, has got implemented, and in this way we are getting this idea. I'm just going through the code once. So just check, we have imported required libraries, then we load this Boston onto this Boston and data dictionary, and then we are just extracting the first 2 columns to define x, and then y will be containing the Boston.target, and then we're just printing this x and y, and now we are defining this random forest regressor class object with random state is equal to 0 and n jobs is equal to -1, and we are printing this object once again. So model is equal to regressor dot fit x and y. We are making the model trained, and now printing the feature importance values and the number of features. I think the conception is getting clear to you. Thanks for watching this video.